All right. Next identities, we have the power reducing identities. These are a manipulation of the double angle identities. Okay. So this one right here, if I took this one and I solve for sine squared, I'd subtract 1 and divide by a -2, and I get sine squared. That's where that comes from. Same for these. I could find these as a manipulation of those double angle formulas. The difference here is instead of going from theta to 2 theta, I'm going from 2 theta to theta, okay? So, or if I'm going this direction, I'm still getting that double angle. And so if I accidentally say the words double angle formula, they're just a variation of the double angle formula. It's the same exact thing. There's nothing new. It's just rewritten, okay? So the direction for these problems says, rewrite each expression in terms with no power greater than 1. So what we're doing is reducing the power. That's why these are called the power reducing identities. So my identity is only cosine squared. So I'm going to rewrite this as cosine squared squared. So this is going to get replaced by this. So I have 1 plus cosine of 2x over 2. So I have to FOIL this and then square this. All right. Now, depending upon the power that you start with, we could be done. We're not done. They want it with no power greater than 1. So I have to change this again, okay? So again, I'm going to use this identity. Now this one, okay, this is theta. This gets to be twice as big because this is already a 2x. In my identity, it's going to become a 4x. So this stays the same. This stays the same. This becomes 1 plus cosine of 4x over 2. And then the whole thing is over 4. So not acceptable to leave a fraction within a fraction. The fastest and easiest way to deal with this is to multiply by 2 over 2. So I have to distribute that 2 all on top. So I get 2 plus 4 cosine of 2x plus 1 plus cosine of 4x. And on the bottom, I get 8. I have 2 like terms, so I can add them together. This is 100% an acceptable answer. In the back of the book, they instead like to write it as 1/8 times 3 plus 4 cosine of 2x plus cosine of 4x. It's the same thing. You don't have to worry about rewriting it. When you get here, you're done. It's correct. All right. Again, rewrite this in terms with no power greater than 1. Okay? So the first thing I'm going to do is I'm going to break it apart. If you have an even powered one, you deal with it like we did the last problem. If you have an odd power one, this is how you deal with it. I'm going to take the sine of theta times the sine squared of theta. Okay? I can use the identity here. So this is going to become 1 minus the cosine of 2 theta over 2. And then this is technically over 1. And so I'm going to distribute my sign. And then technically you're done. Now, in algebra class, a person would argue that because I have 2 variables, essentially, that this would be considered second degree. What they're looking for you is to reduce this so that you do not have any individual trig function that has a higher power than 1, or that they don't have the same argument. And so this is your final answer, and this is entirely acceptable.